Jason.
All right, so uh, yeah, I just the past day and a half, I've finally dove into playing around with the Skynet 20-meter dish at Green Bank, and that's a whole lot of fun. So I'm gonna show my results here. I basically retraced the steps that I took with my small setup using that to see how it would perform in comparison. So I'm going to go ahead and share my screen. And let me see here if I can. There we go. Let's do screen. All right. Can everybody see my screen?
Yep.
All right. I'm going to start this. So basically, I've been retracing like I said, my steps that were presented in my paper with my 3-meter dish, and I've been using the 20-meter dish at Green Bank. It's very straightforward to use. It took a couple tries to figure out exactly what I wanted to do, but my observation settings, I'm using the L-band receiver to do hydrogen line reception. I'm capturing spectra. I put it on the high resolution setting. I did my first one was a low resolution scan, and it just didn't have enough frequency bins to really show detail in the spectrum. So I went to high res, and then I'm using on off scan mode. So I'm taking time on target and then time off target, sometimes multiple in a row, to build up integration time on source, and then using the off target as my reference. One of the reasons for that is that it suppresses a lot of the local Milky Way signal, so that it's not so that it's less of an interference to the extragalactic sources. I ended up using 10 repetitions, 15 seconds on, 15 seconds off, times 10. So basically 2.5 minutes on and 2.5 minutes off. And I've discovered, which you'll see in a minute, that was way overkill for this 20-meter dish. So the first thing so I'm going to put these in order of brightest to dimmest. M31 is large enough that I couldn't actually get the whole thing at once. So I actually took 3 points across the span of the disc. So I did the blue shifted side, then the center, and then the red shifted side. And as you notice, that little spike in the center, right around 1420.4, that's what the residual left over from the Milky Way that didn't get completely removed by the off target reference. But it did suppress it quite a bit. And then I took that data and summed it in a spreadsheet and plotted it and did some background correction. It doesn't look very good because I've only got 3 points and they're real distinct, so I'm not really getting a full integrated spectrum. So let's move on to one that acts more like a point source. So M33, it turned out beautifully. And again, you can see the Milky Way residual signal there as the spike in the middle. And then I pulled the data in again to Excel and used on one of them, I actually used a slight linear correction. So off to the left, you'll see basically I have up to second order polynomial fits if I want to flatten my background. As you can see, I only needed basically a vertical correction on the Y one. So I believe that the two signals are cross polarized, so you get two polarized axes in that receiver. And then M101. And so the reason why the background's a little more messy on this one, or a little more curved, is because M101 is the first one that I did with this longer time, and with the 2.5 minutes on, 2.5 minutes off. And when I did M101, I did one 2.5 minute segment on, and then a second 2.5 minute segment off, and that was it. And so there was a lot more drift in that time of the background. Um, since what I did on the others was I would do 15 seconds on, 15 seconds off, and do that 10 times in a row to build up the 2.5 minutes. And as you can see, it keeps the background a lot flatter because you're correcting more often. Um, Again, the little blip near 1420.4 is the residual Milky Way signal. Now, I just before I came to this meeting, I was playing around. I was actually queuing up measurements from my phone while I was out running around town. I actually, um, I wanted to see what would happen if I used shorter and shorter exposure times. And so I went to 30 seconds on, 30 seconds off. Then I went to 10 seconds on, 10 seconds off, and then 5 seconds on and 5 seconds off. And you still have a clear profile, even with just 5 seconds on target, which is amazing. Okay, so, and then this is, again, this is the corrected, uh, cleaned up version of the data. I downloaded the data files and dumped them into Excel, and then I can do some nice plotting work with them. Then M74, and then we got M81. M81's interesting because it's the Milky Way sits right in the center of it, and so it's hard to get a complete pristine profile because you have that Milky Way signal right in the center. And what that basically means is that its proper motion is almost zero. So it's straddling the Milky Way signal because it's basically sitting still from our perspective as far as radial velocity goes, or it's very small velocity. And then here's NGC 2403. Oh, by the way, if you're wondering why there's two identical plots, in for some reason, when you use high resolution mode, it has the option for two different center frequencies, and I was only using one, so I just programmed them both to be the same. And then here's Holmberg 2. And that's it for this presentation. So yeah, so I've been playing around with that 20-meter dish, and it's really, I was able to do those quick plots where I was doing 10 second, 30 second, 10 second, and 5 second exposure times. I did those from my phone while I was out running around, and I actually accessed the plot from my phone and email it to myself. So I didn't even have to be on my computer to do it. I was able to do it from my smartphone. It was it's really cool. And then it was funny because I was sitting down having a beer and eating my supper, and I thought, well, let's try 1 second. And then it queued up and it did that ready thing, but it wasn't active. And I was like, oh, somebody else is using it. And sure enough, somebody started a 2-hour pulsar track. I was like, oh, man. So, but I'm kind of curious to see what 1 second on will look like. I think it'll still show up clearly with even just 1 second of exposure, which is amazing. And what that proves to me is that I can survey a whole lot of the nearby galaxies with this thing with very small amounts of time and not eating up a lot of the credits. I mean, I can use a handful of credits and get a decent spectrum. So
That's excellent, Jason. That presentation? That's something you could put on the chat.
yeah, sure. Yeah.
I'd love to get a copy.
Yep. Yeah.
It's impressive
Definitely.
too, like you say, controlling systems from an iPhone. I was
Yeah.
able to do that with our dish up at Heathcote too, and it just blows you away, doesn't it?
Yeah. Well, it's kind of funny because yesterday was my birthday, and it was kind of like my birthday present. I got to play with
Yeah,
this big toy, you know. It's like,
many happy returns.
but yeah, I am in the process of one of the things that I came away from the conference with is they were saying bring your dish next year, and I wasn't able to bring my backyard portable collapsible dish because it was just too big to fit in my car, and also it's been kind of deteriorating because it wasn't really weatherproofed, and so the first thing I did when I got back was start designing and building a leaner, meaner version of it that's weatherproofed that I can definitely bring next year. And so I'm putting it through its paces now. It's 2.5 meters instead of 3 meters, so it's slightly smaller. It's got a 0.27 focal focal to diameter ratio, so it's a little bit more curved to try to with the smaller size to try to sink the feed into the dish more and keep the ground interference down. And and so I've been actually doing for the past 5 nights in a row. I've been doing M31 scans, and I am it's definitely not performing as good as the 3 meter one, but I mean it's working. And so now I'm actually starting this evening, or well, actually early tomorrow morning. I'll be doing my first M33 scan with it and see if I can, after about 4 or 5 days, if I can get a clear profile of M33 with that. So.
So do you get the timing data to the GPS reference time that they have in their network there with your files, and are they coming in as spits files?
Well, probably. I mean, I didn't really need, I didn't really care about timing though because I was just looking for a spectral profile.
I
So,
was just thinking though, if you got timing data, then a couple of different people in different places could look at something and do
oh yeah, yeah.
parameters that stuff.
Well, I think actually let me bring up. I'm going to share my screen again and let me bring up one of the files because just to so there's this they call them SIDS files, I guess. But there's also just ASCII files that have the data in them. And so, for instance, let's see. Um, so my M101 file, let's see here. Is this? Let's see if I can. Okay, so here's the M33 file. So there's a bunch of stuff in the header. Can everybody see it?
Yes.
Yep.
And so it does have the date and timestamp on the file. And then um yeah, and
Well,
then all the settings.
it would need to be more accurate than just the header having the date and time. It would need to have, like every data sample should have a time marker on it.
Oh, okay.
And that's a kind of a FITS file format to have the header at the top and then follow that with the data. So it may not be called an FITS file, but it sounds
Yeah.
like that's what you got there.
Yeah,
Bob,
well, and because I'm using spectral files, I'm this this data represents integration over, 2.5, well, actually 5.5 minutes worth of time. So
Bob,
it's
the Skip Curley did a YouTube on this very subject about how to get the raw data from pulsars and from various other things. And so there is a way to get this data, but this is more the common users data profile that provides, but there's also a way to get the internal raw data
mhm.
at whatever you want. And he did there's a YouTube, look for Skip Curley on 21 meter dish, and he's got how to get that detailed data.
That's great.
Also, you guys, everybody in Australia, we've just got the ability to provide for Sarah members the access to this 21 meter remote. So you guys can, as Sarah members, it used to be there was just had to be U.S., but because of the national, the way it was funded, but now we got rid of that. So if you email Steve Zekas, and his email's on the website, then he can give you the password, and you can do what Jason's doing. But you can do pulsars, you can do hydrogen, you can do any objects. And you can do it remotely on your phone, just like Jason's doing. So you guys have that access as Sarah members, and we're funded the account so much, so just don't use up all the time. But we've never used all the time we paid for. So
I was wondering about that. Because when I realized that, that after doing several of them, that 5 minutes of integration time was way overkill. I mean, it was nice and clean, but I did that little experiment just about an hour ago where I cut it down and down. So what I'm wondering is how do I judge if I'm using too much, because I don't want to hog it, but.
Well, if you're worried about it, send an email to Steve Zekas and say, hey, it's okay if I sort of allot 30 minutes or whatever for this month, and he'll tell you how much. He knows what the account numbers are.
Mm-hmm.
And as I'm saying, we've never. I mean, I've played with this thing a couple of years ago, and I was using all sorts of time. So don't feel too guilty about that. You're doing really good work, and this will all be up on YouTube, and everybody will be happy about it. So.
Well, yeah, now that I figured out how to do decent profiles with just, 5 seconds of integration time, I mean, I can go after a whole lot of galaxies and not use a lot of time. I mean,
I think that's what everybody finds out is that they don't need as much time as they originally planned, and it gets less and less for more objects.